Okay, this particular example is kind of a tough one because we need to figure out, we need to really be able to picture something in 3D. And it's something that's not super easy to picture, so I'm going to do my best. But what we're supposed to do in number 34 is write 5 other iterated integrals that are equal to the given iterated integral. Iterated integral. There's a tongue twister. Okay. So we'll come up with some. Okay, I don't know that we'll get to all 5, but we'll get to some. So the first thing that you want to do is think about what region this describes. Okay, and knowing that we've got the x's, the y's, and the z's there. The strategy that you might want to use there is that the first 2 integrals give you the base of a figure, the projection into like that plane, and then this one kind of gives you the height, okay, as a general idea. So the first thing that we want to do is just sketch the region where y is between 0 and 1, okay, again, because our y's are on the outside, and then z is between z equals y and z equals 1. Okay, so in our yz plane, okay, y goes from 0 to 1, and then we want the line y equals z, and the line, z equals 1. Okay, so again, y equals 0, y equals 1, z equals y, and z equals 1. Those are our boundaries. So y equals 0, y equals 1, z equals y, and z equals 1. So we're looking at this triangle right here. Okay. And then we can look at, in the x direction, we're going to get our height. Okay, so x, so think about coming over above this triangle, or I guess kind of out from the triangle if we think about where the x-axis is. X is between 0 and z. So we need to think about x equals 0. Okay, well, that's easy. That's your yz plane. Okay, so that's kind of going to be like one wall of our figure. And then x equals z. Okay, now up here when we're getting the base, we're just thinking about our 2-dimensional base. Now x equals z, we're thinking about in 3 dimensions. Okay, so x equals z is the plane, okay, that would be kind of slicing through, okay, that xz plane at an angle, like, okay. So kind of trying to put this together here the best we can. Okay, so we've got, again, I'm going to label my axes. We have x, y, and z. And then we have that kind of what we call the base here, right? Kind of that back wall. And we also figured out that x butts right up to it. So when x equals 0, so this is like a side of our figure. Okay, so we've got the point 0, 0, 1, 0, 0, 0. This would be the line y equals z, and we'd have the point 0, 1, 1 there. Okay, and then now you have to think about, okay, this other kind of limit in the x direction. So our entire volume has to be within that blue triangle there, coming out of the xy plane and stopping when it hits this plane here. Okay, this x equals z plane. So we got to think about, here's your line x equals z. Okay, and think about it, how that plane would look just kind of slicing through. Okay, we're kind of getting there. You'd be looking at a shape kind of like this, if you can kind of imagine that. Okay, where this side here is part of the plane x equals z. Okay, So it's just slicing right through. So we can label some more points here. This would be 1, 1, 1. This would be, let's see, x is 1, y is 0, and z is 1. Okay, so there's our figure. All right. I guess another way you can kind of think about that is if we have this XY plane, and I'm hoping that you can kind of picture what that is, but only the piece of it that would be up above, but like in the X direction, this triangle. Okay, and that's what I'm saying. It's not super easy to picture it. You might want to graph your XZ plane and just kind of get a better image of what that's looking like. Or I'm sorry, your X equals Z plane. Okay, but this is our figure. All right, it's kind of like this diamond shape. Again, we've got like all of the edges are slanted coming into 0, 0, 0, except for this edge that is on the z-axis. Okay. All right. So now what we want to do is kind of go in reverse and pick a plane that we can kind of easily project into and easily find the height out of, if that makes sense. Okay. I'm somebody who talks a lot with my hands, so as I'm explaining this, like I'm using my hands, and I know you can't see it, but I'm hoping that you can picture it. So we'll do our best though. Okay. So one thing we can think about is, well, obviously starting with that YZ plane was pretty easy. Okay. We can flip that around, right? Instead of doing DZ on the inside and DY on the outside, switch them. And then that X won't really change. Okay. So one thing that we could do then is that going back to this drawing here, how about if we make Z be between 0 and 1? Okay, so your Z is between 0 and 1, and then Y is between 0 and Z. Okay, Y equals 0 and Y equals Z. So then what we can do with that is have 0 to 1, 0 to Z, and then still 0 to Z, because we didn't change. Oh, I guess we should change it. Never mind. Oh, no, I'm sorry. We are in the same, we're still in the YZ plane, so the height is still 0 to Z. And by height, I mean in the X direction, okay? I'm thinking of the YZ plane as the bottom. Okay, so then if YZ is the bottom, then your height is in the X direction. So then we'd have dx, dy, dz. Okay, so there would be one iterated integral that would be equivalent. Okay. Now, the other plane that would be kind of easy for us to project onto would be the XZ plane. Okay, because you can see how there's some symmetry there. So if we look in your XZ plane, I'm going to run out of colors here. Think about this triangle here in the XZ plane. So let me scroll down a little bit. In fact, I'm going to draw it like this. So that this is the positive X and Z, just so that we're not trying to like flip our how we're looking at it. So this would be the line X equals Z, okay, and X is 0 to 1, and Z is 0 to 1, and we're looking at this triangle right here, okay? So that triangle, we can do X is between 0 and 1, and then your Z's, okay, Z is between X equals Z and 1, okay? Or the other way we can do it is Z is between 0 and 1, and X, this direction, is between 0 and Z. Okay, so that would be the other way to look at it. Then we got to think about our height. Okay, so our height, again, if XZ is the floor, that triangle's our floor, the height is in the Y direction. Okay, we're butting right up to that XZ plane. So Y would be between 0 and whatever this slanted edge is here, okay? And that slanted edge there is the plane y equals z, right? It's going right through that line, and it's staying in that same direction, okay? So that would be z, okay? Just like this is the plane x equals z, this is the plane y equals z. So we can set up some more integrals that way. So with this one, we would do 0 to 1 in the x, x to 1 in the z, and 0 to z in the y. And you can see, again, if you kind of want to check, when I do my first integral, I'll throw some z's in there, okay, because I'll integrate with respect to y and then throw some z's in there, but get rid of all the y's. And then in my second integral, I'll take all the z's and throw some x's in there, and then I got rid of all the z's. And then for my final integral, everything will be turned in terms of x, okay? So there's one way to do it. If I want to do it this way, using the same guy here, we could do 0 to 1 dz, 0 to z dx, and then 0 to z dy. Okay, so we've got three new ones. The last one is tricky. And I think I'm going to leave it because I don't want to get anything more advanced than this here. But for your last one, you could project it into, our only plane that's left is your xy plane. Okay, so in our xy plane, we have a square, okay? But the problem is that we have two different heights, okay? We have the height that would have a low point on this yellow side here and a high point on the top, that flat top, or the low point could be on this kind of reddish color one and then the top. So you'd actually have to split it into two separate integrals, which makes it pretty tricky. You have to kind of split it into that kind of all the yellow stuff that's above this triangle, and then all the red stuff that's above this triangle. Okay, so you actually have, the only other ways will include a sum of two integrals. Okay, so I think for now I'm going to leave it like that. But now I'm kind of tempted to finish it. So I guess if you don't want to get confused, if you're like, that was enough, then maybe stop. But I'll grab this. I'll keep going with it. We'll see. Okay, so let me actually erase what I have already drawn, some of this, so that I don't want to have to move that drawing. I'm going to erase some of the work that I've already done. I might regret this later. I might regret undertaking this right now, but I'm feeling pretty good about it, so let's see. I feel like there's probably an easier way for me to erase all this, but not so bad. Okay, so let's take a look, and I'm going to hope that what I do, one little thing, like all of a sudden you kind of just lose your perspective of what the image is showing, and everything's lost, right? But let's go ahead and look. Do you know what I mean? Like you feel like, okay, I can see the picture, it's making sense in my brain, and then you stop for a second and go back to it, and you're like, I don't know how I got any of that. So hopefully that doesn't happen here. But we have our green rectangle again, okay? Or sorry, it's actually a square that I'll divide into two pieces. So we've got this piece and we got this piece, okay? And this is our, again, our XY. Oh, that's not the pen I wanted. Our XY. Okay, so we've got, I'm going to call this one region 1 and region 2. And that didn't show up very well. Let me use a darker green. Region 1 and region 2. Okay, so if we kind of, region 2 is under your plane x equals z. Okay, it's under the yellow piece here. Okay, region 1 is under y equals z. Okay, so under this piece here. All right, So we're going to do each one of those separately. Okay. So for region 1, let's start with region 1. Okay. X is between 0 and 1. Y is between y equals x and y equals 1. The other way we can write it is y is between 0 and 1, and x is between, x would be between 0 and y. Okay, your x values there, between 0 and y. Okay. And then for region 2, I'm going to go over here. We can write that as x is between 0 and 1, and y is between 0 and x, or y is between 0 and 1, and x is between y and 1, right? The x is going this way. Okay. All right. Good so far. Okay, now we just have to figure out the height. Okay, so when we were in that, in region 1, when we're under the kind of reddish one, the lowest we are is at z equals y, and the highest we get is z equals 1. Okay, and then when we're under the yellow plane there, we're between z equals x and z equals 1. Okay, whew, ready? Almost there. Okay, so let me erase all this junk down here. All we need to do now is just put them together. Okay, so for region 1, we can have your integral, let's start with the first one here, 0 to 1 dx, 1 to x dy, and y to 1 dz of fxyz. Okay, or we can do it as 0 to 1 dy, 0 to y dx, and then y to 1 dz. Oops, f of x, y, z. Okay, so there's the two ways that we could write region 1. And then we'll have the two ways that we can, I'm just looking at the, I think I got it. I think it's good. Okay, I might have, let me know if I made a mistake here. I think I'm good. Okay, region 2, we can write from 0 to 1 dx, 0 to x dy, and x to 1 dz. And then 0 to 1 dy, y to 1 dx, and x to 1 dz. Technically, we could get 4 more out of here. The book only takes 2 because they only pair up the 2 that are dz dx dy with dz dy dx. They don't switch them at all, but I mean, it's not technically wrong. Okay, so there's your, what they would consider the 4th and the 5th ones. So have fun with that.